Welcome to my channel. So in this video I am explaining about the difference between correlation and covariance, because these are the two statistical factors which are used to compare two inputs or two functions. So if you want to understand what is correlation, just you watch my previous video. I am also providing the link in the description of this particular video part. Now, correlation, covariance. So both are used to get the linear relationship between any two quantities. Two quantities means two vectors, two samples of values. I have one data in one quantity, let me say x, and another data in another quantity, let me say y. So now x is having certain set of values and y is having certain set of values. And remember here, the length of x should be equal to the length of y, means the number of values in the x should be equal to number of values in the y. Two quantities, two functions should have same values, then only we can find correlation or covariance. If we have less in one, higher in other, then correlation or covariance calculation, it is not possible. So the first condition to calculate either covariance or correlation is the number of samples in each and every vector should be same. Okay, now these correlation, covariance both are available in Python statistics library. So first of all, let us import statistics as st. Okay, now let me take two values, let me take two data points. Okay, so for this I'll use a range function here. So I will take list of range, let me say -5 comma then 6 comma 1, and another vector also I'll create another sample y equal to list of range of, let me say, 5 comma -6 comma -1. So that is what I will do. So here first I'll print what is x and what is y. So this is x vector, then print y vector. Okay, all right guys, so first let us execute this. What could be the x and y? Yeah, so now from the result it is clear that you see x is having approximately 11 values and y is also having 11 values, so both are same. So let us find that. So also I want to print the length of x, and also I would like to print length of y, because the sample size should be same, right? So length of y. Okay, now if I print it, you see both are having 11 elements. You see x values are starting from -5 negative number and they are increasing, finally they are settling at 5. And coming to y values, it is starting from positive number and it is slowly decreasing. Now let me find the correlation first. Okay, so I will say p1 equal to st dot correlati, correlation function is already, we know this, x comma y. Okay, so now I would like to say print, so p1. Okay, right, now what this is giving is, let us see, we are getting it as -1, means they are opposite correlated. So they are strongly oppositely correlated, means one function is increasing and the other vector is decreasing. Okay, x is like increasing and y is decreasing, exactly 100% they are in opposite direction. So that is what the conclusion that we make. But what about covariance? Now let us find it. st dot covari, covariance. I want to get the covariance between x comma y. So now I would like to print p2. So print p2. So now if I execute this program, the result will be, see, it is giving -11. Okay, so friends, what we can understand from this correlation and covariance, so both are giving the linear relationship between two quantities. Both are giving the linear relationship between two quantities, but only the difference is covariance will tell you whether they are varying in a similar manner or in opposite manner. But how much similarity is there, you cannot find out from the covariance. See, this value can be -11. So if I change the values of x and y, this can become -20 also. It doesn't mean that they are strongly correlated. So how much effectively they are correlated, whether they are correlated strongly or weakly, so that measure we cannot do with covariance. So covariance will just show the behavior, but it will not tell you the level of the relationship, whether they are strongly correlated or weakly correlated. So whereas correlation coefficient will tell you whether how they are varying and also how much strongly they are correlated. So whether it is opposite correlation, so in this case both are varying opposite. What it indicates? -1. So -1 here indicates that both the quantities are exactly opposite, 100% they are opposite. So that is what you have to understand from the correlation. So correlation will tell you the level of the relationship also, but covariance will tell you only, it will tell you the behavior, it will not specify the level. So that is what the fundamental difference between covariance and correlation. And mathematically I have shown the correlation formula in my previous video. If you didn't watch that, please watch that video also. I will give the link in the description of this video. And coming to covariance, so if you want to calculate the correlation or correlation coefficient R, so you should calculate covariance. So what I mean to say is the formula which will use for correlation calculation, so in that formula we will have a covariance. So without calculating the covariance we cannot directly calculate the correlation. So correlation will be the end result, covariance will be the primary result. So fundamental difference, once again I am telling you. So covariance will be only specify the type of relationship, whereas correlation will specify the level of the relationship also. So let us change the input here once again. So let us do it. So what I will do is I will change my input. So let me take for example, so 10 comma 4 comma 5 comma 8 comma 5. Okay, so these 5 values I took. Then I will check another things. So something like I want to start from 1 comma, so 7 comma 3 comma 5 comma, so 9. This is what. So the length also 1 2 3 4 5 5 elements. Then if I execute this program, so you see this. Now in this case these are negatively correlated. So the level of the relationship is minus 0.6. So they are opposite but not to 100% opposite. There are, I can say 69% of opposite. But whereas you see the value covariance, it is also giving minus 5.5. So we cannot judge anything from minus 5.5. So level of correlation we cannot expect from the covariance. So this is what the main difference between the correlation and covariance. So these are very important statistical parameters and which are very much helpful for any data scientist. I hope you understand the exact difference between the correlation and covariance. So thank you guys.